So good afternoon. Thank you all for taking the time to attend this IsoDraw webinar on optimizing the technical illustration process. So I just want to go through a quick couple of slides with you first before Rob Wood's demo. So again, first of all, welcome. So what we'll be going through today is a 2 seconds, just got a quick note. You should all be allowed to add in chat bar as well. So if there is any questions, please save them for more towards the end. If everyone could let me know that they can hear me, that would be fantastic. It seems to be the majority. If anyone does have any technical difficulties, we will be sending out a recording at the end. So we just wanted to touch on quite briefly what is a technical illustration. That's always a good place to start. Where are the pain points in kind of typical process that we encounter today, optimizing your illustration process by leveraging your 3D CAD data, and then of course the technical demonstration by Rob. So, I mean, what is a technical illustration? Basically, in layman's terms, it's what is it? What does it look like? And it's more of a simplified view for the operation and service of your products. So you can see exactly what's what you need, and in what order to put it together. There's a couple of examples on the screen there. How to load the tool, parts list, assembly list, and such. So of course, that's an engineering drawing on the left. That might be perfect for somebody building it or initially putting it together in the factory before sending it out. But to the customer, they'd probably like something a bit more simplified on the right about how to actually put it together. So this is an example of what IsoDraw will do. This is what Rob will be working towards in his technical demonstration about how to put this together. Standardly, it'll take around about 15 minutes, but of course Rob's going to be demonstrating some of the extra functionality in there as well. So it'll take up to around about 25 minutes to half an hour. So technical illustrations are all about bridging the gap between CAD and publishing. I mean, what we usually find is you have your, of course, engineering design, mechanical engineering, product designers designing away, and it has to wait until that design is finished before it's sent over to your technical publications team, maybe even your marketing team, to start the process of putting the document together. And of course, it can't really be sent out into be manufactured or to the customer without having that technical publication. So you can see the kind of current processes at the moment down at the bottom, and the consequences, of course, are always important to avoid. So time to market with having that kind of manual, inefficient transfer of information. So if there's any changes, they might not be communicated effectively, resulting in costly rework of the technical publications team, and that having massive backlog on time. So IsoDraw in your technical publications looks to bridge that gap, so your designer can start passing over the information to the technical publications team through the means of IsoDraw, in order for them to start working with it, working on placement and different views earlier on. They're working concurrently together to get that faster time, to improve the satisfaction of customers, and to make sure those changes are communicated efficiently. You can see I'll take a range of CAD data from Pro Engineer, SolidWorks, CATIA, your UG and NX as well, whether other sources, and bridging that gap. So it's basically a one tool for all your illustration tasks. So you can use it as just 2D. You can bring in your 3D models as well, which Rob will be moving on to show you. And the leveraging of your 3D CAD data as well. So save you having to take perhaps a screenshot, send that over to your technical publications team or your marketing team. They go back to the design engineers. Can you turn it slightly to the left for me? Take another screenshot, send it back over. Or what normally happens is you wait for it to be built. People take pictures and the pictures then put into a Word document. So it's all around improving your time to market, so you can make sure what you have is where you need it to be for when the product is to be released. So what I'll do, I will hand it over to Rob Woods for the fun part of the IsoDraw demo.
Luke's shown you there an example earlier on of what we can achieve with IsoDraw, and that's what we're going to strive towards this afternoon in a short time to actually put that illustration together. Now, I'm not going to concentrate too much on specific tools at this point or sort of individual functionality of tools and so on. If there's any queries, perhaps we can take those offline later on, but what I want to go through today is the process of actually taking in existing CAD data, creating line art with it, and adding to that with perhaps our own library parts and adding function, if you like, to that illustration to make it a usable illustration rather than something that's sort of a CAD dump, an image from dumped straight out of a CAD system and used that way. So we're trying to add value to the data. So what we're going to do, this is our interface then. I've got an empty page on screen here. Let's start by closing this down, and we're going to go File, New. Now we've got an option to create a new empty page. In this case though, you'll see I've actually got a series of formats already created. I work as a freelance illustrator, and so I've got a number of different clients, each work their own different ways, and so I have formats set up specific to those customers. It might well be though that if this is used internally within a business organization, you might have different formats, one for a user manual, one for an illustrated parts catalog, one for exhibition output, that sort of thing, anything like that. So it's still a usable function. So we're going to take our demo format, and you'll notice now we've actually got a landscape format. So this is now an A4 landscape page. I've got an image area ready to go. So we've got a green line here which represents my print area, if you like. And then outside of that, standard common used parts, which we use during our illustration creation. Bottom left-hand corner is a control number all in place, ready to go. And bottom right-hand side, we've got a little logo, the company logo. Just a brief explanation then. I've actually got this set up. If you're already familiar, for example, with things like Adobe Illustrator or Corel Draw, you'll be quite happy with the way this works. We work in much the same way. We have our layers, pens, fill windows, all that sort of thing. So it's nothing, the interface might look different, but essentially everything works and looks in just the same way. So let's make a start. We're going to do File, Open. And from the list here, this is a good example, actually, a good place to actually start and say, right, this is all the different file formats that we can work with. So at the top end, we've got our standard 2D formats, so our EPS files, CGM, Illustrator, and so on. Then we look at the 3D parts, the 3D formats. So we're working through IGES, obviously PTC's own formats in here as well, the PRT and ASM files. step files, parasolid files, VRML and so on. There's all the 3D data. Then we've got the raster formats, TIFF, JPEG, PNG. Yeah. Oh. Okay then. Right. I'll slow down then. Okay, fair enough. Yeah, I probably ought to say I actually live out in the sticks, and we're lucky to get telephones at all out here, let alone broadband. Got it. Okay, thanks, Luke. Yeah, so I was just trying to explain there with the different file formats that we can handle. Hopefully you can all see that. There is a bit of lag. I can just actually notice in the preview window there. It might just be that this particular dialog doesn't show, but we can handle then the standard 2D formats, EPS, Illustrator, and so on, most of the 3D file formats, and then the raster formats as well, so TIFF, JPEG, EPS. So if we want to be able, for example, to trace off a photograph, we can bring a TIFF file or a JPEG file and trace off and so on. So we're going to concentrate initially here with an IGES file. Now I've got a base plate IGES file here ready to go. Now we've got a series of individual then dialogues here which are specific to the file format. I won't go and explain all the different functions and all the different checkboxes, but each sort of file format will then have its own process to go through. So we'll just OK through these until we get to this dialog here. Look, now this is sort of the first point at which you get to see the content of that model. So what we're looking at here is design data which was created by the engineer when he built the 3D file. If he associated a part name or a part number with that 3D geometry, we get to see it here as well. So essentially there's a series of checkboxes ahead of that enable us to do this. So we can see then a complete breakdown of the model. That's just OK. Looking at my preview here, it looks like we're all we should all see this. So we've now got then the 3D data imported into IsoDraw, into CAD process. First thing we're going to do is to switch this around to a 3D view. And I do need to just delete one item off the back there. There's for some reason or other this particular model has a duplicate part. So our base part here, the base plate that we're going to use for the illustration is now imported. Now I'm going to come back to this. The first thing I'm going to do for our illustration is create a locator view. And so I'm going to capture this. This is our sort of hidden line view. So we switch the color off, gives us a better chance to see what's going on. I'm going to go straight to our camera button along the top bar here. Look, we've got a camera, and if I click a series of options, I'll explain them a little later on exactly what's going on here, but let's just for the moment let's just say OK, and that leaves the model open, but then in the background I have a new untitled view, and there's the illustration. So it's created for us a 2D piece of line art, and if I just switch the preview on, we should be able to see here, look, we've got our thick and thin line. If you're familiar with the technical publications standards, if you like, we use a process called thick and thin, which gives us an ability to just add a little dimension, a little depth to the illustration. So where we would be able, for example, to get our hand behind a part, we use a thick line. Where we wouldn't be able to get our hand behind, we use a thin line. So there's a little cylinder here with a hole in the top. I would be able to get my hand or a finger or a pen inside that hole, so the front edge is thick, the back edge is thin. That standard then, that's an industry standard, if you like, to use this technique. IsoDraw applies that technique for us automatically. We don't have to think about it. We don't have to ask it to do it. It does it automatically. So there's our illustration ready to go. You'll also notice that we've got some blue lines appearing on screen. A blue line is an engineering line. It's what they call a surface border. And it's where, for example, if we look at the cross member here at the bottom, we've got, for example, a radius along here. So it starts, the sort of top plane comes around, it curves on a radius and then drops down to an output edge, if you like. Now those lines, as an illustrator, I don't want them all, but they describe the shape. So we